Hey guys, hope you all enjoyed your weekend. That you had that nice, easy assignment on Friday, and I appreciate the feedback that you gave me. It's nice to know that I'm doing some things that your other classes are doing, and I'm glad that some of you are appreciating the fact that I'm spreading it out a little bit. Anyway, on to part 2 of this. Now, there are 2 things that you need to go along with this video. You're going to need your blue sheet, okay, and you're going to need your book, because the problems I'm going to be doing are going to be coming right out of the book, as example problems. And your blue sheet is critical because we're going to learn about the t distribution, which is one of the 2 that's on the back. It's table C. So if you need to pause the video, go ahead and pause it and go ahead and get that stuff. All right, so in case you don't remember from the last video, the biggest thing that I told you is that you must know sigma, which is the population standard deviation, in order to do a z critical value, or a z, in order to do a z confidence interval. If you do not have sigma, if sigma is unknown, then guess what? You must use a t distribution. Okay, now what in the world do I mean by a t distribution? It is very similar to a z distribution, but there's a couple of differences. And what I'm going to do is I'm going to pause the video, I'm going to write down some stuff, and then all of a sudden it's going to show up. So here you go. Okay, so how is a t distribution the same as a z distribution? Remember, there were 8 characteristics of the z distribution that you had to write down on your last test. Hopefully you're remembering them. The 4 that are the same are that a t distribution is bell-shaped, it is symmetrical, the mean, the median, and the mode are all equivalent, and the t distribution never touches the axis. So basically when you're drawing these, when you need to draw a t distribution, if you need to draw a t distribution, it's the same thing. It looks the same almost. Some very important differences. The variances, or in other words, sigma squared, will always be greater than 1. Okay? And obviously it's not sigma squared, it would be the sample squared. The family of curves is based on degrees of freedom, which is related to the sample size. That's the big key to this. If you pay attention to the video, you'll see that that's where we really need to be careful. And as n increases, as the sample size increases, it starts to approach the standard normal curve. All these families approaches the standard normal curve. Okay, so what next? Okay, degrees of freedom. I usually write that as df. You all can certainly write that as df too, as well. For these, when we're dealing with a t distribution, the degrees of freedom are n, which is the sample size, minus 1. A lot of people like to forget to subtract 1. I don't know why. It's very important. That's why I put a box around it and a star and things like that. But the degrees of freedom is n minus 1. And the formula for the error, okay, which also will help us determine sample size, is t of alpha over 2 times s, which is the standard deviation of the sample, divided by the square root of n. Okay, or as it does tell you on your sheet. Okay, n is equal to the quantity T of alpha over 2 times S over E squared. Okay. So, big important part. If sigma is known, what do? We use z of alpha over 2. If sigma is unknown, we use t of alpha over 2. And guys, all we're going to be doing is confidence intervals and sample sizes again. Just like we did with when sigma was known, now we're going to show you how to do them when sigma is unknown. Okay, so as I told you, you need your blue sheet and your book. So make sure that you have those, okay? And the first thing we're going to do is we're going to look on page 374. And we are going to look at problem number 4 to tell us how to figure out the t-distribution critical values. Okay. Now, problem number 4a, it says, find the values for each. You want to find t of alpha over 2, so I want t of alpha over 2 when n equals 18, and my confidence interval equals 99%. Okay. Guys, this is so easy. Make sure you're looking at table C, which is the back page. All right. Go all the way down to the bottom. You will notice that down at the bottom it says 50%, 60%, 70%, 80%, 90%. Those are your confidence levels, guys. So for problem 4a, if I want a confidence interval of 99%, I'm going to go over to the first, second, third, fourth, fifth, sixth, seventh, eighth, the ninth column where it says 99%. Now, n equals 18. Well, if I look on the left-hand side where it says df, I go down to 18, but what do I need? If n is 18, my degrees of freedom is equal to 18 minus 1, so I want to look at 17. So I go down to degrees of freedom 17, and I go over to the 99% column, and what number do you see? Hopefully, you all see the same number that I see. T of alpha over 2 is equal to 2.898. Okay? Does that make sense? Hope so. What about B? For part B, you are given n equals 23 and a 95%. Sorry about that. 95% CI. So what am I going to look at? Well, I'm going to go over to the 95%, which is the first, second, third, fourth, fifth, sixth column. And I'm going to go up. Remember, my degrees of freedom equals n minus 1, which in this case is 22. So I go up to 22, that fifth column over, and what do you see? T of alpha over 2 is equal to 2.074. Okay? What do you think? Pretty straightforward? I think so. So let's go ahead and do C, D, and E, just to be on the safe side. C, you have 15 and 98%. Okay, so that means my degrees of freedom is equal to 14. Okay, so I go down to 14 and I go over to 98%. And hopefully you guys get 2.624. What's really nice about this is that you guys just have to be able to read this table. And eventually, I'll show you how to read this table and get Z's off of it too. And you'll be like, what? All right, D. For D, you have n equals 10. And you have a 90% CI. Okay, so my degrees of freedom is going to be equal to 9. So if I have 9 and I go over to the 90%, which is the fourth column over, I get 1.833. And now let's do E. I have n equals 20. And we have 95% again. So remember, the biggest thing you got to remember, do the degrees of freedom. Degrees of freedom equals 19. So you go to 19 and 95%. And you should get 2.093. Right. Hopefully that makes sense. Now, notice though, that if once you get over 30, you've got a problem, because look at your left hand side. Left hand side goes 1 to 30, and then it goes to 40, 50, 60, 80, 100, and 1,000, and infinite. Okay. You can never have more degrees of freedom than you than what you have. So basically, if you have something like 35. What you're going to do is you're going to, and you do -1, you end up with the degrees of freedom of 34. You're going to drop down to 30. You can't have as many. You can't go up to 40. You can never round up. Just drop down to the nearest one closest to it. Okay. So we have T of alpha over 2 is what I'm looking for. And what if I say n equals 35? And I want a 90% CI. All right, so my degrees of freedom are going to be 30, 34. But again, I don't have 34, so what did I say you need to do? Do I go up or do I go down? I go down. And then, so I go to 30, and I find my 90%, and I get 1.697. Hopefully that makes sense to you. Okay. That's that part of it. Okay. So now let's do some actual problems. Now that you know how to find your T of alpha over 2. Problem number 5 is the first problem we're going to do. Problem number 5 says the average hemoglobin reading for a sample of 20 teachers was 16 grams per 100 milliliters, with a sample standard deviation of 2 grams. Find the 99% confidence interval of the true mean. Okay, so conditions, guys, need to test for. So from here on out, I'm going to be looking for you to be testing for these conditions each time. Okay. First thing you test for is SRS, which is a simple random sample. Okay. Now this problem doesn't say that the sample was random. It just says it was a sample, so we have to assume. So what you would do is write SRS, assume. Typically, SRS will be either assume or given. If it tells you it's random, then you can say it's given. If it doesn't say that it's random, then you have to assume. Easy enough? I hope so. you test for independence. Okay. Now, what does independence mean? That means that that the total population of whatever it is that we're looking at has to be greater than or equal to 10n. And when we say total population, we're talking about in the world. Okay. Now, in this problem, our n is equal to 20, and it's 20 what? It's 20 teachers. So, ladies and gentlemen, is there more than 20 times 10 teachers in the world? Yes, there's more than 20 times 10 teachers in Frederick County. So, since there is at least 200 or more, then we can call this a normal distribution. Okay? These conditions are going to change later on, so we need to be careful. Okay? But we'll always check for the same three things. Okay. Now, well, actually, we can't say that's normal. Let me erase that. That's the third thing we're testing for. That was independent, so we can say it is independent. Okay. And then the last thing we test for is normality. Okay. In order to have normality, n must be greater than or equal to 30. Just that simple. You're just checking to see is the number that you're testing greater than or equal to 30. Well, no. In this case, it's not. Our n is only 20. But look at what the directions say. It says for exercises 5 through 20, assume that all variables are approximately normally distributed. So even though our n is not greater than 30, because we are told that we can assume that they are, we can say that normality is given. Okay. Now, before you start any problems, guess what? Those three things you're going to have to show me. You're going to have to show me on quizzes, on tests and things like that. And you're going to have to write them down on your homework because we're going to talk through them as we go through. So it's just part of stats, guys. All right, so there's our conditions. Now we can actually do our problem. Now, do we know the standard deviation? No, we don't know the standard deviation. It says it's not a population standard deviation. It is a what? A sample standard deviation. So it is not sigma, it is S. Since it is not sigma, then we need to do a t-test. If it was sigma, we would do yes, that's correct, we would do a z-test. So our formula for our problem is basically almost exactly the same as what we did before. X bar plus or minus t of alpha over 2 times s over the square root of n. Okay, well, it says that x bar is the average was 16, so we've got 16 plus or minus t of alpha over 2. Well, how do we find t of alpha over 2? Oh yeah, we want to go back and onto our blue sheet and find our t score. So we had 20 teachers, so n was 20. So what's our degrees of freedom? 19. And we wanted to do a 99% confidence interval according to the problem. So we go to 99% and we go to 19, and what do you find there? 2.861. And then S was given to us, was 2. And don't forget, this is the square root of n, so this is the square root of 20. Okay. And once again, guys, X bar drives everything. Okay. Some of you, I noticed, were not cutting off your confidence intervals correctly in the homework that we did before. 16. Okay. Now you can come up with a number that has more than one decimal place, but in this case, guys, it rounds to 1. Okay. You can't go any further, it can't go any less. So this becomes 16 plus or minus 1, so it becomes 15 is less than mu. We're still looking for the population mean, which is less than 17. So yeah, guys, that 100 milliliters that's in the problem, that means nothing. Okay, that's just the way hemoglobin is read. It's per 100 milliliters. Okay, so what do I still need? Mr. Drum, do I really need to? Yes. I am 99% confident that the true mean hemoglobin reading is in my interval. Okay. I know it looks like a lot, but really, truly, and honestly, it really isn't. You guys can definitely handle this kind of stuff. Okay? I have confidence in you. I hope that you have confidence in yourself too. Okay. 2 more. I think we'll do 2 more, and then that'll be enough, because I think we'll probably hit the half-hour mark on the video, and I really don't want to go any further than that. All right, so the next problem I want you to look at is number 9. Okay, that's the one that says college wrestler weights, and remember, we're on page 374 for those of you who have forgotten. So let's write down the key things about problem number 9. First off, a sample of 6 college wrestlers. Okay, so n equals 6. Okay, well, that's a horrible 6. Try again. That's even worse. I can't write. There we go. Has an average weight of 276 pounds, so x bar equals 276. Okay. With a sample standard deviation of 12 pounds. So again, this is not sigma, this is S. So since we have a sample standard deviation, I hope you all are listening to this, a sample standard deviation, that means that we have to use a what? A t-score. Okay. All right, we want a 90% CI. Okay. And then if a coach claimed that the average weight of the wrestlers on the team was 310, would it be believable? Well, we'll work on that later. Let's get our confidence interval first. All right, remember, we're dealing with this now. What are the 3 things we need to test? We need to test our conditions, so I'm just going to write down the words conditions. Maybe you guys should too. Okay, first off, SRS. Once again, it just said it is a sample. It doesn't say that it's random or not, so we're going to say that we have to assume. Okay. Independence. Remember, n has to be greater than or equal to 10. I'm sorry. The population has to be greater than or equal to 10n. So do you think there are more than 60 wrestlers in the world? I think so. So independence is good. It is independent. And of course, normality. We want n greater than or equal to 30. It is not, but again, what did the direction say? We can assume that the data is normal. All right. So, what do? Well, we go right back to our formula. X bar plus or minus t of alpha over 2 times s over the square root of n. Once again, we have everything that we need except for t of alpha over 2. And t of alpha over 2 comes right off the chart. Okay? What are the two things that you need to know? You need to know your n, and you need to know your confidence interval. N is 6, so what's our degrees of freedom? 5. So if we have 5, and our confidence interval is 90%, we just go to where 5 and 90% meet, and hopefully you come up with the same thing that I did, 2.015. All right, so let's plug in our numbers. 276 plus or minus 2.015 times 12 over the square root of 6. Please don't put the degrees of freedom in here. I've seen students do that, and it does throw the answer off a little bit. Okay, so, ladies and gentlemen, once again, what is x bar? It goes to the whole number, so I can do 276 plus or minus. When I do all of this, when I do this multiplication and everything, the nearest whole number is 10. Okay? So that means our confidence interval is going to be 266 is less than mu, which is less than 286. Because again, we're doing a confidence interval on a mean. Okay? So what do I still need? I am 90% confident that the true mean wrestler weight is in my interval. Okay. Great. Now there's still one more part, isn't there? What's the last part of this problem? If a coach claimed that the average weight of the wrestlers on his team was 310, would that claim be believable? Well, if we're 90% confident that the average weight is between 266 and 286, is 310 believable? No. I'd say that would be a little bit not believable. Now, what if I said that the average weight was 290? Well, we're 90% confident that it's between 266 and 286. 290, is that pretty close to 286? I'd say yes. So could that be believable? Yes. But 310, that's a bit off. Okay. All right. Last problem. Okay. Let's go ahead and do number 13, students per teacher in U.S. public schools. Okay. Once again, we're just going to start by writing down the important stuff. Okay, so the national average for the number of students per teacher for all U.S. public schools is 15.9. So average means x bar, 15.9. right here you can tell how far you're going to be able to take your confidence interval. You're going to be able to go out to the tenths place, and that's it. A random sample of 12 school districts from a moderately populated area. Oh, look at that. Showed, so n is equal to 12. Showed that a mean number of students per teacher was 19.2. So we have another average. That's interesting. With a variance of 4.41. So S squared is equal to 4.41. Okay. Estimate the true mean number of students per teacher with 95% confidence. How does your estimate compare with the national average? So our confidence interval equals 95%. Our degrees of freedom is going to equal 11. Okay. Now, guys, which one of these averages are we going to use? Well, we are going to use the second average because that's the average of the sample. And be careful. Now remember, it said variance. Because it said variance, I wrote down S squared. I need what? I need S, so I'm going to need to take the square root of 4.41 somewhere. Okay, so you got to read what you're given. If it says variance, make sure you take the square root of it. All right, how do I start? Our conditions. Okay, SRS. What do you think? Given or assume? It says a random sample of 12 school districts. So if it says a random sample, guess what? That's given. Okay. Independence. That means that we have to have a population greater than or equal to 10n. So do you think there's more than 120 school districts in the world? Yes. So population greater than or equal to 120. So we can say yes, it's independent. And then our last thing that we check for is normality. And again, in this problem, we only have an n of 12. We normally check for n being greater than or equal to 30. But again, this is still before number 20, so what do we say? Normality is given. Okay? Normally we would have to assume, but it's given. Okay, so what do we do? We've got our x bar. Which x bar are we going to use? We're going to use the 19.2 plus or minus, what's t of alpha over 2? Well, let's figure it out. All right, what two things do I need? I need our confidence interval, which is 95%, and I need 11 degrees of freedom. So 95%, 11 degrees of freedom. Hopefully you're all coming up with 2.201. And again, it said the variance was 4.41, so if I want S, I want the square root of 4.41 over what? The square root of 12. So guys, you have to pay attention to what's given to you in the problem. If you don't pay attention to what's given to you, then guess what? Then you're probably going to get something wrong. So we do our math, we get 19.2 plus or minus, how much are we going to add or subtract? 1.3. Okay, so what does that give us? That gives us 17.9 is less than mu, which is less than 20.5. So what? You still have to write your conclusion. I am 95% confident that the true mean number of students per teacher is in my interval. Okay. How does your estimate compare with the national average? Well, clearly, our estimate is above the national average. Okay. So I would say this area is different than the national average. Because remember, the sample that we have was a moderately populated area. National average takes into account everything, right? What do you think about an urban school? Do you think that there might be more or less students per class? Just things to think about as you go through, and as you start reading statistics in the paper and things like that, you'll be like, wait a minute, there's some things that are weird about this. Okay, you'll be able to this class will help you be able to take the news a little bit differently. Okay, all right, guys. It's a lot of stuff to watch. I'm not going to give you anything else today. Tomorrow, be ready for some more problems. Thank you and have a wonderful day.